All right, let's talk about section 4.2, implicit differentiation. Now, as I'm looking at that, I realize I didn't use very good penmanship there, but it's implicit differentiation. Before we actually get into the guts of this lesson, I want to talk about two concepts just kind of abstractly that will tie into the lesson. So the first one is, let's let f of x, so that's again bad penmanship here, but let f of x equal u cubed minus u, okay? And I'm going to tell you right now that u is sine of x. So if that was the case, if I gave you this function, I said find f prime of x, this is what you would do. Sorry, I just knocked my charger out of my computer. Okay, this is what you would do. You'd get f prime of x. You would recognize that u is actually a function in itself. So this is a chain rule question, right? So this would be 3u squared times by the derivative of u, which is u prime, minus the derivative of u, which is u prime. Okay, what is u prime? U prime is equal to cosine of x. Okay, so, sorry, this would be f prime of u if I stopped right here. I could keep going. I could get f prime of x, but f prime of u would be this, all right? So if what we're deriving is a function, then the chain rule is required, right? So if what we're deriving has a function within it, then the chain rule is required. U is a function in and of itself beyond just the independent variable. Therefore, it requires the chain rule. So there's one fact, one concept that we need to kind of pin in our mind here. The next one is this. If I give you something like this, y squared equals x, this is not a function. So if you put this in Desmos, Desmos will happily graph it. But this is what you'll see for the graph. It is a sideways parabola, okay? Is it a curve? Yes. Can it be graphed? Absolutely. Is it a function? Not at all, all right? And so it's not a function. However, we could ask questions like, what is the slope of the tangent line at the point 4, 2? So if you go 1, 2, 3, 4, and up 2, imagine this was at 2. Hey, look, it is. That's 2. All right, so at the point 4, 2, we could ask the question, well, what's the tangent line there? What's the slope of the tangent line? What is the tangent line? That kind of thing. We could also ask, what about at 4, -2? Right, same kind of thing. 4, -2. It's -2 because I say it is. Same kind of thing. We could say, well, what's the slope of the tangent line there? All right, so this is a curve where it's not a function, but we could ask the question, can we find tangent lines on this curve? Okay, this curve, this equation is called an implicitly defined function. It's implicitly defined because implied within this equation is the following. y1 is square root of x, and y2 is negative square root of x. In other words, if you square root both sides, you get plus or minus square root of x. You get the positive root x here, the negative root x here. It's called an implicitly defined function. Equation. It's an implicitly defined equation because these functions here are implied in the equation, all right? So let's actually find the equation of one of those tangent lines then. So for our first example here, we are going to find dy dx in the example, and then ultimately we want to find the slope at the point 4, 2. Okay, so we'll start with this. Y squared is equal to x. All right, and then we want to take the derivative. So I'm going to take the derivative of both sides with respect to x, dy dx, or d dx on the left, d dx on the right. Now that notation we talked about earlier in the year briefly, but that is like you're saying you're taking an action to derive the thing on the left and the right with respect to x. So on the right, when you derive x with respect to x, you just get 1. That's the independent variable is x. Okay. On the left, when you derive this with respect to x, you will get a chain rule problem because y is itself a function. Y is the dependent variable. Okay. So I will get 2 times y, subtract 1 from the power, I get 1. And then times by the derivative of y. Well, that is no longer, it is not 1 because y is a function. So it is dy dx based on the chain rule. Just like up here, when we said we got 3u squared times u prime, down here, I'm going to get, I'm going to get 2y to the 1 times dy dx. I could write y prime here. You got to be careful because it looks like a 1. So anyway, I get 2y dy dx, okay? And then if I want to get dy dx by itself, I have to divide both sides by 2y. So this is what I get. Dy dx is equal to 1 over 2y. All right? And that answer, that solves the first part, right, which is find the derivative. So we've got that. Now the question is, what about this slope at 4, 2? Well, if I want the slope at 4, 2, then here's what I will do. I will just take my expression, dy dx. And now I have to take into account both x's and y's. So previously, when we just had functions, we would just plug in the x value to get the slope. Now, if we have an implicitly defined function, we need to pay attention to both the x and the y. So, sorry, this is 4, 2. So I'm going to plug in 4 wherever I see an x, there is no x. I'm going to plug in 2 wherever I see a y, there is a y. So I'll get this 1 over 2 times 2. So my slope is 1/4. All right, and we can do the same thing for the slope at 4, -2, but I don't think we need to. So there's one example of a simple implicitly defined curve where we find the, just need to find the derivative and the slope. Okay, so let's go on to another example here. Next example here. Let's look at, same instructions, we're going to find the derivative with respect to x, and our problem is going to be x squared plus y squared is equal to 25. Okay. So I want to take the derivative with respect to x, dy dx, or I want to find dy dx, so I'll take the derivative with respect to x on both sides. When I derive x squared, I'm going to get 2x. Nothing changes there from previously. Now I'm taking the derivative of y squared. It's going to be 2y dy dx, because it's a chain rule problem, right? 2 out in front, subtract 1 from the power, times by the derivative of y, which is dy dx. On the right, derivative of 25 is 0. So this is what I get. Now, I'm going to solve for dy dx, because I want to get that by itself ultimately here. So minus 2x minus 2x. So I get 2y dy dx is equal to negative 2x. Divide both sides by 2y, and I finally get dy dx is equal to negative 2x divided by 2y. Simplify that real quick. I get negative x over y for my derivative with respect to x. So if I was asked to find the slope at a point, I would have to plug in both x's and y's here. Okay. And you know what? It might be worth putting this down right now. So here are the steps for finding the implicit differentiation. Okay, 1, you differentiate both sides with respect to x. Step 2, collect terms with dy dx to one side. So far, we haven't had to worry about these 4 steps too much because the problems have not been that complicated. But as they do, these 4 steps will be helpful. Factor out dy dx. And then step 4, solve for dy dx. Okay, so we didn't need to really do this collect terms with dy dx on one side or factor out dy dx on these 2 examples that we had here. So let's do one where we actually do need to do that. So let's go with this. So we want to find the derivative again. Here's my equation. 2y is equal to x squared plus sine of y. Sorry, there we go. 2y equals x squared plus sine of y. Hey, Joe. So I'm going to take the derivative first. So I will get 2 dy dx. On the right, I'll get 2x plus derivative of the outside is cosine. So I'll get cosine of y times dy dx. Now, this is a situation where I have two dy dx's. In order to fix this, I've got to get both dy dx's on one side. So I'm following the 4 steps, right? So differentiate both sides. Now I got to collect the terms with dy dx to one side. So here we go. I'm going to move this cosine to the left, cosine dy dx to the left. So I get this 2 dy dx minus cosine y dy dx equals 2x. Okay? Then I'm going to divide out the dy dx from both terms. So factor out the dy dx from both terms like this, dy dx times, and I'll be left with 2 minus cosine of y equals 2x. Finally, I'm going to divide both sides by this expression to get dy dx by itself. So I end up with, so if I divide this by 2 minus cosine y, 2 minus cosine y, this is what I get. Dy dx is equal to 2x over 2 minus cosine y. And that's my final answer for the derivative on that one. Okay. Again, we've got x's and y's both showing up. It's not a problem. Last one. Okay, so for today, or for part 1 here. So we want to find the slope of the tangent line. So let's write this out. We want the slope of the tangent line at -1, 2. Okay, and here is the equation that we are going to be analyzing. X squared minus xy plus y squared equals 7. And now I'm going to derive, and I have to be very careful right here because this expression in the middle is a product. And it's very easy to miss that this is a product. So when we derive it, we're going to get 2x minus, and then we're going to have the product rule here. So it's going to be first times the derivative of the second, dy dx, minus the second, or sorry, plus the second, which is y, times the derivative of the first, which is just 1. And then we have to derive y squared. So we'll have plus 2y dy dx, which equals 0. All right, so clean up. We need to distribute the negative through, so I get 2x minus x dy dx minus y plus 2y dy dx. Next step is collect all the dy dx terms on one side. So I'm going to move the y over to the right. I'm going to subtract the 2x over to the right. So I end up with this, negative x dy dx plus 2y dy dx equals y minus 2x. I did it a little differently in my notes, sorry. Okay, I'm going to divide out the dy dx, so I get this, dy dx out in front, and then I'll have negative x plus 2y equals y minus 2x. And then I'm going to divide both sides by negative x plus 2y. So I end up with this, dy dx is equal to y minus 2x divided by negative x plus 2y. And there's my derivative. So I've got the derivative now, the derivative expression. I want actually ultimately the slope of the tangent line at -1, 2. So I'm going to plug in -1 and 2. So I'm going to evaluate this at -1, 2, and I'll get this. Dy dx is equal to, so I have y, which is 2, minus 2 times -1, divided by negative of -1 plus 2y. So plus 2 times 2. And so I end up with 2, actually I should just keep working down the, well, I guess it doesn't matter. 2 plus 2 is 4, divided by 1 plus 4, which is 5. So I end up with 4/5 for the slope there. All right, so that gives you an idea of how implicit differentiation works. And then in the next video, we'll talk about how to take higher order derivatives in implicitly defined equations. The one thing I actually did want to show you is that you can, using Desmos, you can get a picture of what this graph is going to look like. So if you drop this in, I should have had this ready already, I apologize. X squared plus xy plus y squared equals 7. You can get it will show you what the graph looks like. This happens to be an ellipse, and you can look at the graph at -1, 2. So at -1, 2, which would be right here-ish, you get a slope of Oops, it should be minus. Sorry, it's like my slope's not right. There we go. Get a slope of positive 4/5, which is, I don't know, I buy that. Just kind of looking at the what the imaginary tangent line would be right there. So that's implicitly defined curves, part 1.